Good morning, good afternoon, and good evening to everybody, whatever time you're watching this. My name is Praveen, and my project is called BioProc. Uh, I'm gonna agree, it does feel a little weird. It feels like I'm talking to my laptop, uh, but I am gonna try the best that I can. Uh, so BioProc is basically a signal processing library that I try to write for EMG, ECG, and EEG data. Uh, I plan to finish up on EMG for this class and later extend it to ECG and EEG. The main reason that I wanted to go ahead with this idea was that there is no dedicated library for processing biological signals. There are a lot of signal processing libraries, but nothing dedicated for biological signals, especially EMG, ECG, and EEG combined together. Uh, Another reason that I took up this project was I was very interested in classification of the signals in order to diagnose patients. For example, with EMG, it is possible to diagnose normal, healthy individuals, people who suffer from myopathy or neuropathy, and likewise for ECGs, it is possible to classify them into people who are healthy, people with arrhythmias, and other cardiovascular diseases. So my goal for this library is to develop develop it into a full-fledged library for processing EMGs, ECGs, and EEGs, and also be able to classify data into normal and disease population. I hope over time that I have enough data to classify them into particular diseases too. Uh, I hope that this will give a lot of people at least the opportunity to visit their doctors and do a checkup rather than wait until it's too late. So there, like I mentioned, there are a lot of functionalities from NumPy, SciPy, and Pandas. But my aim has been to give a library that makes it extremely easy for the user. I have combined all of these functionalities such that all that the user has to do is just input the signal and the processing will get done on its own. So I basically divided the structure up into two categories. One that contains the functions for all of these signals, and the other category will be functions specific to EMGs, ECGs, and EEGs. So far, I'm done with the functionalities for all of these signals, and I have also worked on the EMG signal. I hope that in the future I'll be able to work on the ECG and EEGs. One of the lessons I learned was that writing a library is not easy. In fact, in my mind, I thought it would be extremely easy and I would get done with it really soon. But a lot of issues always crop up, and it was extremely hard for me to work all of it through and make sure that there was a working library. Also, because of the fact that once you're writing library, you have to think about a lot of different aspects. A big kudos to anybody who's worked on writing libraries like NumPy, SciPy, all of those things that we use extensively. More than me explaining about the functionalities of my library, I figured that it would be easier to just actually show you the code and what exactly it's doing. So I want to show you some of the functionalities that are possible using BioProc. Uh, I've simulated EMG signal using a couple of random numbers. And as you can see, I'm filtering it using a Butterworth filter second order. I'm bandpassing it 50 to 450 hertz. I'm not mentioning any of the cutoff frequencies or the sampling frequencies for the function because I have already inputted all of these. These are the default values are already there, but the user does have the option to play around and change things if he wants to. Um, I've also inputted a periodogram function for power spectral density. And also, in order to find the correlation, a correlogram function is available. Um, so I've have basically tried to uh, combine three sine waves together, each of 100 frequency, 50 hertz, 100 hertz, and 200 hertz frequency. Uh, so the inbuilt function pad size basically takes in the size of the signal and accordingly adds the best possible zero padding. Uh, the Fourier function, of course, finds the fast Fourier transform of the wave of the signal. And as you can see, we've got 50 hertz, 100 hertz, and 200 hertz, just like the signal we inputted. But instead of making the user do all of these things, the user does have the option to do all of these things individually using my library. But I've also written EMG process function, wherein you just given the input signal, it's automatically going to find in the filtered signal, the FFT, as you can see, the full wave rectified signal. The blue here is the raw signal, and the orange here, as you can see, is the full wave rectified signal. It's also capable of finding the envelope. Another way to find the smooth signal is to use the root mean square. I've written a function for that too called RMS underscore sig, wherein you just pass in the input signal along with the window size that you want for the root mean square. And as you can see, it automatically calculates the root mean squares of the signal and plots it. Uh, One of the things that we do using EMGs is trying to understand when the movement starts, when muscle activation takes place. So I have written a function for that called find onset, as you can see here. So I have loaded up a signal, one of the example signals that I've got, and I've ran the find onset function. And as you can see, basically found the onsets of muscle activation over here. The blue color over there is the EMG signal, and the orange is the onset for the signals. My concluding remarks and future work. Yes, my concluding remark would be that probably after a week or so, open up your terminal and pip install BioProc. Even if you don't process EMG, EEGs, and ECGs, do a friend a favor and go ahead and install it. And also, I'm always welcome for any kind of feedback, any inputs. Feel free to email me. I am planning on finishing up on the EMG classification by this week. So it should be able to classify between myopathy, neuropathy, and healthy patients. Later, I plan on working on the ECG classification and the EEG classification. Hopefully, within a short span of time, it should be able to classify diseases and diseased population and healthy population and help people out. Thank you for listening. Take care and stay healthy.